That's cheating. All right, think of dot products. What makes a dot product as large as possible? Yeah, when the vectors involved are parallel. So in other words, if a velocity field actually is pointing in the direction of a tangent vector, so it's actually taking you around this point, then this is going to be larger. But this essentially is equal to this constant pi a squared times the curl dot product with the normal vector. All right. Here again we have a dot product. What makes this as large as possible? Well, when the normal and the curl are parallel. All right. So what ends up happening is when the velocity field is parallel to the tangent vector, I'll just use t in this case, for the unit tangent vector, then what's happening is the circulation is maximized. At the same time, the circulation is also maximized when the curl of V is parallel to the normal vectors, which is the axis of circulation. So if the vector field is swirling around like this, then what is it doing? The vector field is rotating around this axis, the normal vector. So in other words, the curl of V at any particular point, what it tells you which axis of rotation maximizes circulation. So the direction of a curl indicates this axis. All right, now I've talked about the magnitude of a curl before. The magnitude tells you something different. The magnitude of this vector curl V indicates a measure of a tendency of a fluid to be rotational at that point. So if a curl is 0, the vector field is irrotational. You're not going to see any whirlpooling at all. There's no vorticity to it. But when you do have a non-zero curl, the magnitude tells you the tendency of the fluid to rotate around that point, and the direction indicates the axis of rotation. Okay. So once again, by looking at everything as the vector field involved as a velocity field of a fluid, we see how physical interpretations of things like curl or divergence can come about. All right. Okay. Questions, as we're almost out of time? All right. One topic left, and that is the divergence theorem, which we'll see on Tuesday, and then no more Stewart.